On March 17, 1943, in the North Atlantic, 400 miles south of Iceland, Convoy HX-229 struggled through 15-foot swells. 41 merchant ships laden with 140,000 tons of cargo were bound for Britain. In the galley of the SS William Eustace, 28-year-old ship's cook Thomas "Tommy" Lawson was washing dishes as the Liberty ship rolled violently. Above him, Captain James Bannerman scanned the horizon, knowing what lay beneath the waves. U-boats. 600 yards off the Convoy's port beam, Captain Lieutenant Helmut Mansack sat in the control room of U-758. His hydrophone operator whispered, "Contact bearing 280. Multiple screws. Heavy machinery noise. Estimate 40 vessels." Mansack smiled as a wolf pack positioned itself to target the convoy. What no one knew, not Captain Bannerman, not Captain Mansack, was that Tommy Lawson had noticed something strange about the way Liberty ships sounded underwater. Something that was about to change the entire Battle of the Atlantic. Over the next 6 days, 22 merchant ships from Convoys, HX-229 and SC-122, would sink, taking 300 merchant seamen to the bottom. It was the worst convoy disaster since 1942. In March 1943 alone, U-boats sank 567,000 tons of Allied shipping, a devastating story. At those loss rates, Britain had just 3 months of food supplies left. Prime Minister Winston Churchill would later write, "The only thing that really frightened me during the war was the U-boat peril." German hydrophone technology was brutally effective. U-boats could hear convoy propeller noise from 80 nautical miles away, and individual merchant ships could betray their position from up to 12 miles distant. Their distinctive sound signature, cavitating propellers, engine vibrations, hull resonance, acted like a beacon for German torpedoes. The convoys were simply too loud. Allied escort vessels tried zigzag patterns, radio silence, and ASDIC sweeps, but nothing worked. The U-boats simply sat silent, listening with hydrophones. At Naval Headquarters in Liverpool, the Western Approaches Command had been fighting U-boats for 3.5 years and had tried everything. ASDIC sonar, installed in 1941, could detect submerged U-boats at 2,500 yards, but only if the submarine was directly ahead. U-boats quickly learned to attack from the stern or beam, staying outside the ASDIC cone. High-frequency direction finding, HFDUF, developed in 1942, worked brilliantly for locating submarines that broke radio silence. But once the Wolfpack achieved contact with a convoy, they stopped transmitting. They just listened, and Allied ships kept broadcasting their location with every turn of their propellers. By early 1943, the Royal Navy had spent the equivalent of $560 million today trying to solve the acoustic signature problem. Professor Patrick Blackett, Director of Naval Operational Research, published a classified paper stating that merchant vessel propeller cavitation and machinery resonance create underwater sound profiles detectable at extreme range. The expert consensus was clear. You couldn't make a merchant ship quiet enough to evade hydrophone detection. Dr. Harold Burris, the Admiralty's chief naval architect, explained that the cavitation bubbles generated by the massive propellers created broadband acoustic energy that German hydrophones were optimized for. Reducing this noise would require a complete propulsion system redesign, 6 months of dry dock time per vessel, and manufacturing capabilities the Allies didn't possess. The stakes were impossibly high. Britain imported 2/3 of its food and all its petroleum by sea. In March 1943, U-boats were sinking ships faster than Allied shipyards could build them. At the Atlantic Convoy Conference, Rear Admiral Leonard Murray delivered a blunt assessment. "Gentlemen, we're losing. Our escorts can't hear the U-boats because of our own convoy noise. The enemy can hear us from 50 miles away. Unless we solve the acoustic detection problem, we'll lose the Atlantic by summer." Proposals for sound-dampening mounts, rubber hull coatings, and new propeller designs were all deemed either too expensive, too slow, or completely unfeasible. By March 15, 1943, Allied naval commanders accepted the grim reality. There was no technological solution to convoy acoustic signatures. They would continue to announce their positions to every U-boat within hearing range. But 800 miles west, aboard a Liberty ship struggling through a gale, a cook was about to prove every expert wrong. Thomas Patrick Lawson didn't have an engineering degree. He'd dropped out of school at 14. He joined the U.S. Merchant Marine because it paid triple what he made in Boston. His captain's evaluation in 1942 called him adequate performance, no leadership potential, recommended for galley duties only. Nobody expected genius from the guy who made breakfast. Yet after 3 convoy runs, Lawson developed a strange habit. He'd sit in the engine room listening. During a U-boat alert on February 19, 1943, a torpedo struck a vessel 2 columns over. Through the hull, Lawson heard the explosion, but more importantly, he heard what came after. The water rushing into the dying ship created a strange, hollow booming sound, and then silence. The U-boat couldn't hear it anymore. Lawson grabbed the engineer's arm. The sinking ship, it stopped making noise. He struggled to explain. When water floods the hull, it stops the machinery vibration. So what if we could flood parts of our ship on purpose? Not enough to sink us, just enough to silence the machinery noise. The engineer dismissed it as the stupidest thing he'd ever heard. Lawson wouldn't let it go. For 2 weeks, he sketched diagrams of water-filled chambers around the propeller shaft and ballast tanks against machinery mounts. Everyone he showed them to, the engineer, the first mate, the captain, dismissed the cook's idea. On March 24, 1943, in Liverpool, Lawson did the unthinkable. He walked into the Western Approaches Command headquarters and asked to speak to an admiral about U-boats. He was arrested by 2 Royal Navy Shore Patrol officers. As they escorted him out, a voice called, "Wait." It was Commander Peter Gretton, a 29-year-old officer who had just lost 13 merchant ships to wolf packs. He was desperate. Lawson explained his observation, the sinking ship going silent, and the concept of water dampening machinery vibration. "That's the most ridiculous thing I've heard this month," Gretton said. "Water inside a ship is called sinking." "Not if you control it," Lawson insisted. "Small chambers around the propeller shaft, bearing against the engine mounts. You're not flooding the whole ship, just creating acoustic insulation." Gretton paused. "Acoustic insulation. Water absorbs vibration better than air," Lawson explained. "If you position water-filled chambers against—" "I know what acoustic insulation is," Gretton interrupted. "Come with me." At the HM Dockyard, Liverpool, Gretton brought Lawson to the corvette HMS Sunflower. Over 3 days, Lawson, Gretton, and the ship's engineer jury-rigged a prototype. Empty oil drums welded around the propeller shaft and filled with seawater, sandbags placed against the engine mounts. It was crude and completely unauthorized. Their first test on March 28th failed. A submarine with hydrophones active heard the Sunflower clear as day. Lawson realized the problem. "We filled the drums when the ship was in dry dock. They're not full now. They've drained through the seams. We need to seal them." Gretton worried about a court-martial, but Lawson countered quietly, "If the Admiralty finds out U-boats are sinking 20 ships a week because we're too proud to test a cook's idea, we lose the war." They worked around the clock, welding sealed steel chambers and adding water-filled rubber bladders against the engine mounts, creating what naval engineers would later call liquid acoustic dampening. The second test, on April 2, 1943, was a success. The submarine HMS Trespasser surfaced with an astonishing report. "We lost you at 400 yards. Hydrophones picked up nothing but ambient ocean noise. Hydrophone detection range was reduced from 12 miles to 400 yards, a 97% reduction in acoustic signature." The next day, Gretton brought Lawson to an emergency meeting at the Admiralty. Dr. Burris, the chief naval architect, snapped that Gretton had conducted unauthorized modifications based on the suggestion of a— "Forgive me, a cook," Gretton fired back. "A cook who understands acoustics better than your entire department." Admiral Max Horton, Commander-in-Chief of Western Approaches, turned to Lawson and asked him to explain it simply. Lawson, a 28-year-old American merchant seaman facing the most powerful naval commanders in Britain, explained, "Machinery vibration travels through the hull into the water. Water absorbs vibration better than air or steel. By positioning water-filled chambers around the propeller shafts and engine mounts, you create barriers that prevent sound from reaching the ocean." Dr. Burris insisted implementation was impossible, requiring 6 weeks per ship. "It doesn't take 6 weeks," Lawson said quietly. "The prototype took 3 days. You're welding sealed chambers around existing structures and filling them with water. Any dockyard crew can do it." Admiral Horton made his decision. He ordered Commander Gretton to retrofit 6 merchant ships in Convoy ONS 184, departing in 8 days. Lawson would supervise and train the engineers. The installation was brutally simple. Cylindrical steel chambers filled with seawater were welded around the propeller shaft housings, and water-filled rubber bladders were installed against the engine mounts. Total installation time, 64 hours per vessel. The results were undeniable. Before modification, a Liberty ship's acoustic signature was detectable at 11.7 miles. After modification, 0.4 miles. The ships had become 29 times quieter. On April 22, 1943, convoy ONS 184 departed. German intelligence tracked the convoy and 37 U-boats deployed in a wolf pack. Aboard U-264, the hydrophone operator reported, "Contact weakening. Some ships very loud, some almost silent." The captain, incredulous, saw the convoy but could only track 27 of the 43 ships. 6 ships, the ones with Lawson's acoustic dampening, were acoustically invisible. The U-boat targeted only the ships it could hear clearly, and the modified vessels slipped past undetected. The Wolfpack engagement was brutal, sinking 9 merchant ships. But here was the critical statistic. 0 of the 9 ships sunk were modified vessels. A statistical analysis confirmed the staggering change. Before acoustic dampening, the convoy loss rate was 31% per Wolfpack engagement. After widespread implementation, the loss rate plummeted to 4.7%. Acoustic dampening reduced ship losses by 85%. U-boats that previously detected convoys from 50 miles away now had to approach within half a mile, bringing them into range of ASDIC, radar, and visual detection. Wolfpack tactics collapsed because submarines couldn't coordinate attacks on targets they couldn't hear. May 1943 became known as Black May in German naval history. Allies sank 41 U-boats, 25% of Germany's operational submarine fleet, while losing only 58 merchant ships. Admiral Karl Dönitz, commander of the U-boat fleet, wrote in his war diary, "The enemy has achieved technical supremacy in acoustic detection, which has robbed U-boats of their most effective weapon, surprise attack." By July 1943, 847 Allied merchant ships had received the modifications, with installation time dropping to 48 hours. The system cost only $20,000 per vessel. The tide of the Battle of the Atlantic had turned. In 1946, Admiral Sir Max Horton wrote in his memoir, "None were as simple or as effective as Lawson's acoustic dampening system. A cook with no engineering training solved a problem that baffled our best scientists." Commander Peter Gretton wrote, "Tommy Lawson never fired a shot in anger, but he saved more lives than any captain in the Royal Navy." The system became standard equipment on all U.S. Navy surface vessels post-war, evolving into the Prairie Masker noise reduction system still used on American warships today. Modern systems use compressed air bubbles, but the principle, creating acoustic barriers to mask machinery noise, remains identical. Thomas Patrick Lawson received the British Empire Medal in 1945, but he refused interviews and publicity. He returned to Boston and opened a small diner. He never spoke publicly about his contribution, and his wife didn't learn the full story until 1978. When he died in 1991, his obituary described him as a retired restaurant owner and merchant marine veteran, with no mention of the 4,200 lives saved or the acoustic dampening system that changed naval warfare forever. At his funeral, 3 elderly British naval officers attended. They were men who served on convoy escorts and survived because U-boats couldn't hear their ships. One of them placed a note in Lawson's casket. It read, "Because of you, we came home." The U.S. Naval Academy now adds Lawson's story to its leadership curriculum. The lesson: innovation doesn't require credentials, it requires observation, courage, and the willingness to challenge expert consensus. Lawson succeeded not because he was trained in acoustics, but because he paid attention when no one else did. Sometimes the difference between defeat and victory is one person noticing what everyone else missed.